All right, the next thing we're going to talk about in Chapter 2 is something called a conditional statement. It is where we have a logical statement that has two parts, a hypothesis and a conclusion. Now, much in the same way the scientific process has a hypothesis and a conclusion. The nice thing about this is true and false doesn't matter in this part, not like counterexamples and stuff. What we're going to do is we're going to take a statement and break it into its two parts. If it is raining, then there are clouds. We can see right away that if it is raining is the hypothesis, there are clouds in the sky is the conclusion. And notice how it's written as an if-then. That helps us identify the hypothesis and the conclusion. We get if, the hypothesis, then the conclusion. That's how you write an if-then. If there's something going on, then something else is going on. This ties in a lot with cause and effect. If it is raining, the cause, then the effect is there are clouds in the sky. We're going to practice that. We're going to practice rewriting some of these statements as if-thens. The first thing we get, excuse me, all birds have feathers. Now, regardless, don't worry about if that's true or false. Let's look at the statement. All birds have feathers. Can you think of a way that we can break this down into an if-then statement, keeping the same ideas, that all birds have feathers? We could actually split this right up into two different parts. All birds and feathers. We could identify this as the hypothesis, the hypothesis, and this is the conclusion. The hypothesis being if something is a bird. If an animal is a bird, the conclusion to that would be that it has feathers. If an animal is a bird, then it has feathers. Excuse me. There we took our statement, all birds have feathers, and broke it down into an if-then. If an animal is a bird, then it has feathers. Let's look at the second one. Two angles are supplementary if they are a linear pair. Again, we want to take this statement and write it as an if-then statement. Now, the first thing that we get is we have an if right here. Now, it's written second. Two angles are supplementary if they are a linear pair. This is written kind of backwards, but we still take the same idea. Angles are supplementary. They are a linear pair. But since this one follows the if, that makes it the hypothesis or the cause. The conclusion would be that if something is a linear pair, then it's supplementary. Now we want to write it as an if-then. The hypothesis always goes first, so if they are a linear pair, what is they? The angles. If two angles are a linear pair, then the conclusion, which is they are supplementary. Then they are supplementary. You might be saying, well, why are we doing all this writing? This is stupid. There's no math in this. This is a lot of math. This is theory. This is where math started, was in theory. You made an observation, like we did last section. Maybe it was that every time you have one of something and you add one of something, you have two of that something. But then there are also times when you need statements. You don't need a mathematical sentence. You need a statement. Math is part of science, and science deals a lot with this stuff right here. And so it's important that you understand it. Again, identify the hypothesis and the conclusions. Now this one already has the if in place. That helps us identify the hypothesis and the conclusions, but we actually have to write it as an if. Notice how we have the if then statement. If two angles are a linear pair, then they are supplementary. Okay. Now I know that this is new and it's kind of confusing and you're wondering, how is this math? Trust me, this is a difficult section or a difficult chapter for a lot of people. That's why we go slow and just take it for what it is. If we're dealing with conditional statements, try and understand conditional statements. Don't try and apply it to what you just learned. Don't think of where we're going in the future. Just take it for what it is and move on. So let's move on. If I told you the front wall and the back wall intersect, how would you tell me the opposite? What would the opposite statement look like? Let's talk about this. And this is just taking a statement, okay, a logical statement, like what we just dealt with, whether it's a bird and feathers or angles and supplementary. Let's talk about the front wall and the back wall, I'm telling you, intersect. How could you tell me the opposite? Well, it'd be really simple. You'd tell me they don't intersect. You would say something simple like the front wall and the back wall don't intersect. Okay? You would tell me, no, they don't. Okay? Still the same statement, but you would throw in something that means no, the opposite of. Okay? If this is a yes, you could make it the opposite statement by throwing in a no or a don't. And that's called the negation. The negation of a statement is the opposite of an original statement. And it's really simple. You throw in a no or a don't or a can't. Something that means the opposite of. Let's look at a couple examples. If I told you the ball is red, how could you negate that statement or write the negation of that statement? It would be something simple like the ball is not red. And I want you to think about this. If you told me the ball is blue, would that be the negation of this sentence? Or would that just be a totally different sentence all in of itself? Yeah, that would be just a total sentence all in of itself. When you have a statement like the ball is red, and you're told to write the negation of it or to negate it, then you have to write the same sentence, but make it not whatever it originally was. Let's try another example. Let's tie in some math and say if n equals 9, then n squared does not equal 81. Now, again, don't worry about if this is true or false. Let's just worry about the negation of it. How could we write the opposite of this statement? What do you think? This has already got a not in it. N squared does not equal 81 is already negated. So when we make it negated again, or when we negate it again, or write the opposite of it, it becomes like a positive statement. We take out that negative part. If n equals 9, then n squared equals 81. Go back to the ball. If I told you the ball is red, you would tell me the opposite by saying the ball is not red. If I told you that if n equals 9, then n squared equals 81, and you told me the opposite, you would tell me if n equals 9, then n squared does equal 81. So think of the negation as the opposite of an original statement. And that'll help you, whether the opposite involves a ball being red or something squared being 81. Now, we're learning all of this so that when we go ahead, we're not getting really, really confused. Let's look at these two theorems. Theorem 3.1 says alternate interior angles theorem. Now, this is something we're going to get to eventually, but we haven't got there yet. It says if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. Let's look at the second one. Alternate interior angle converse. This one's the alternate interior angle theorem. This is the alternate interior angle converse. This is something very important that we're going to talk about in a second. Let's read it. If two lines are cut by a transversal so that alternate interior angles are congruent, then the lines are parallel. Let's look at what these two statements do. One talks about two parallel lines cut by a transversal. And again, don't worry, I know that you don't know what they mean. Don't worry about it. Let's just look at the wording. Let's just look at what's talked about. If two parallel lines are cut by a transversal, then they're congruent. Here we have, if two lines are cut by a transversal and they're congruent, then they're parallel. Here we're going from parallel to congruent. Here we're going from congruent to parallel. And the two lines, by the way, mean parallel. You can see that right here. The converse is like the opposite of. Okay? It's not the negation where we're going from something to the not something. But converse means the opposite. We flipped a statement around. We went from parallel to congruent. The converse statement is going the complete opposite way. What topics do they cover? Well, they cover parallel lines and alternate interior angles. You're going to be learning about alternate interior angles here coming up pretty soon. What specifically are they trying to show? They're either trying to show parallel lines or congruent angles. How are they worded? They're worded opposite. One of them is talking about parallel lines being congruent. The other one is talking about congruent being parallel lines. And you're going to see this a lot as we go through the book. Eventually, we're going to start learning lots and lots of theorems. And then the very next thing you're going to learn is the same theorem, but it's converse. The same ideas being talked about, parallel lines and alternate interior angles, but this time they're going to be actually worded differently. And again, that's called a converse. When you take a, not the shoe by the way, but when you take a statement, flip what it says around, that's called a converse. And again, we're learning all of this so that what we learn about coming up is not so confusing. And this is it. This is where a lot of kids get caught in geometry. This stuff is very, very difficult to understand. That's why we're spending so much time on it. Other than making a conjecture, finding a counterexample, identifying the hypothesis and conclusion, in an if-then statement, there are different ways to write a conditional statement. We could take a conditional statement like birds have feathers and write it as an if-then. Okay? But there are also different ways to say it. If we have a conditional statement, like right here, if the measure of angle A is 99 degrees, then angle A is obtuse. That makes sense. You could rewrite that to say if angle A is obtuse, then the measure of angle A is 99 degrees. We flipped that statement around. Okay? The converse was written where we exchanged the hypothesis and conclusion. Earlier, you were told to write if hypothesis, then conclusion. The converse of a conditional statement is saying if the conclusion, then the hypothesis. You even saw an example of that right here. Two angles are supplementary if they are a linear pair, where the hypothesis actually came second. We're going to learn about conditional statements, converse statements, okay, which is just a conditional statement flipped around. Then we're going to learn about something called an inverse. And an inverse of a conditional statement is the negation of both the hypothesis and the conclusion. So let's look at this. Let's look at our conditional statement. And I know that this is a lot, very, very quickly. In fact, I know that a lot of you are confused. Just stay with me and it will make sense. The majority of the time in geometry, when you're introduced to something the first time, you're confused. But as you see it a second time, like on the homework, and as you see it a third time, like tomorrow when we discuss it, the more we discuss it and the more you're introduced to it, the more you come in contact with it, the better you'll get at it. So we have a conditional statement, and it says, if the measure of angle A is 99 degrees, then angle A is obtuse, which makes sense. Now we're dealing with the inverse, and the inverse is taking that statement and make it negative. If the measure of angle A equals 90 degrees was our conditional statement, now we just make it negative. If the measure of angle A is not 99 degrees, then we take our conclusion, then angle A is obtuse, and we make it negative. Then angle A is not obtuse. And again, making something negative or negating it is very simple. Just say the opposite of it. Then we deal with something called the contrapositive. And the contrapositive is the exact same thing. It's the negation of, but instead of the conditional statement, it's the converse. So if we take the converse, if angle A is obtuse, then angle A is 99 degrees, and we make it negative. If angle A is not obtuse, then angle A is not 99 degrees. So again, we started off with our conditional statement. Okay, here we go. Starting point. We flip the hypothesis and the conclusion. In fact, we're going to start with our conditional statement. Okay? The first thing that we do is we write the converse of it, where we flip the hypothesis and the conclusion. And we can even see that. Conditional statement says that angle A is 99 degrees, then angle A is obtuse. If we flip that, we get if angle A is obtuse, then angle A is 99 degrees. The next thing that we do is we write the inverse. The inverse is taking the conditional statement and making it negative. We take whatever our conditional statement says, and we make both the hypothesis and then the conclusion negative. For example, our conditional statement read, angle A is 99 degrees, then angle A is obtuse. We take both parts, the hypothesis and the conclusion, and we make them negative in the inverse. If angle A is not 99 degrees, then angle A is not obtuse. Worded the exact same, but it's negated. It's the opposite of what it reads. The next thing we do is we go to the contrapositive. The contrapositive is taken off of what the converse says. If I look at how the converse is worded, I negate that. I take the hypothesis and the conclusion in the converse and just make them negative. So the converse reads, if angle A is obtuse, then angle A is 99 degrees. The contrapositive is just that statement negated. If angle A is not obtuse, then angle A is not 99 degrees. Look at those steps. You start off with a conditional statement. You use the conditional statement to write the converse, and the conditional statement to write the inverse. Then you get to the contrapositive, but the contrapositive uses the converse statement to be written. And again, I know that this is a lot very, very quickly. In fact, now that everyone's confused, let's practice. We're given a statement here. Guitar players are musicians. Now, regardless of if that's true or false, who cares? Step one is write the if-then form of the above statement. And we're going to get our conditional statement off of this. So how could I write this statement right here as an if-then? Well, very simply. If you play the guitar, then you are a musician. Again, true and false it doesn't matter. Now, we're going to go to step 2. Flip-flop the hypothesis and the conclusion. Here's my hypothesis. Actually, that's not true. My hypothesis is right here. You play the guitar. My conclusion is you are a musician. The if-then stay in the same spot. And we flip-flop them to rewrite our new statement. So it's going to be conclusion, hypothesis. And now we rewrite our statement. If you are a musician, then you play the guitar. All we did was just flip what was written. We flipped the hypothesis and the conclusion to make our converse statement. And that's step 2. Step 3 deals with the inverse statement. Now negate both the hypothesis and conclusion in your conditional statement. So we're going back to our conditional statement that looks like this. Except we're told to negate them. And we're going to rewrite it. So I start with if. And now we need to negate this sentence. You play the guitar. Well, the negation of that is you don't play the guitar. That's pretty easy. You don't play the guitar. Then we take this statement, you are a musician, and we negate it. That's easy. You are not a musician. You aren't a musician. That's not too tough. Again, we just took the conditional statement and negated it. Now we go to the contrapositive. And the contrapositive is exactly the same as the converse, except it's negated. So I look at how my converse statement was written, and it was written like this. I really like the highlighted parts because it keeps my hypothesis and conclusion separate. I can see how each one flips. So again, I'm going to write my hypothesis, then my conclusion, or my conclusion, then my hypothesis, excuse me. But now I'm going to negate them. The converse statement reads, if you are a musician. Well, I'm going to negate that. If you aren't a musician, then, and up here it reads, you play the guitar, but I'm going to negate that and say, you don't play the guitar. Now, this is a great tool. This page of your notes is a phenomenal tool. Phenomenal. Because what it does is it walks you through writing your conditional statement, taking something and making it an if-then, and even identifying the hypothesis and the conclusion. And then it walks you through writing the converse statement, writing the inverse statement, writing the contrapositive statement. It walks you through them, and you can actually see, now you can see on mine, you might not have highlighters like I do, but it helps you see where the conclusion goes, where the hypothesis goes, and how you just negate them. Now, the only two that get negated are the inverse statement and the contrapositive. The other two, the conditional and the converse, are just, they're just flip-flopped. Okay? And again, I know that this is a lot, but again, the more you practice this, the better you'll get. Take a look at how each of the statements you just created in step 1 through 4. Now go through and decide whether each statement is true or false. What do you notice? Well, let's go back. The conditional statement read, if you play the guitar, then you are a musician. And would you classify that as true or false? And I would say that's true, because if you play the guitar, you can qualify yourself as a musician. Let's look at the converse statement. If you are a musician, then you play the guitar. Well, I know lots of musicians that don't play the guitar. They play a different instrument. They might play the drums, or they might play the cowbell. Just kidding. But that's not a true statement. You don't have to play the guitar to be a musician. The inverse statement. The inverse statement reads, if you don't play the guitar, then you aren't a musician. Now, like I just said, you don't have to play the guitar to be a musician. I have friends that play the drums very, very well, and they consider themselves musicians. Let's look at the contrapositive statement. If you aren't a musician, then you don't play the guitar. Well, listen, if you aren't a musician, well, I would dare say that you can't play the guitar. And the reason that's true is because if you did play the guitar, then you would be a musician. But you're not a musician, so you probably can't play the guitar. Okay? I doubt you would consider yourself a musician, if you couldn't play the guitar. Let's look at it again. Example 2 says, write the if-then form, the converse, inverse, and contrapositive of this conditional statement. Now, I'm going to help you identify the hypothesis and the conclusion. That way you can go through and label and then fill out the if-then, the converse, the inverse, and the contrapositive. If a polygon is equilateral, then the polygon is regular. So, the hypothesis would be what? Polygon is equilateral. What would the conclusion be? The polygon is regular. Okay? Let me label those really quickly before you go off on your own. Okay? Hypothesis. Conclusion. And now go through the if-then, the converse, the inverse, and the contrapositive statements. Look back at this example, example 1. See how we took a statement, made it an if-then. Then, see how we did the converse statement. See how we did the inverse. See how we did the contrapositive. I want you to practice right now in example 2. Pause the video, and then when you're done with those 4, hit play. All right, hopefully you had long enough to write down those 4 statements. If not, pause the video and try that on your own. It does no good to keep hitting play and watch how I do it correctly. You need to take chances. You need to try this on your own. If you get them wrong, who cares? Nobody's there to watch you. You need to practice this. Watching me do it correctly every time is not going to help you. You need to use these examples to practice on your own. Let's go through and identify the hypothesis and conclusion. This statement is already written in an if-then form. So I can just copy it into my if-then. The hypothesis stays the same. A polygon is equilateral. The conclusion stays in the same spot. The polygon is regular. When I write the converse, I'm going to flip those. I'm going to get if, whatever the conclusion was, then the hypothesis. And so my converse statement reads, if a polygon is regular, then the polygon is equilateral. See how I just flipped the hypothesis and conclusion? Now, the inverse is the if-then negated. So I'm going to write the same thing where it goes hypothesis, then conclusion, just like in my if-then or in my conditional statement. But I'm going to write not. I'm going to make it a not statement or a negative statement. And I can even see here that my if-then or my conditional was a polygon is equilateral. The inverse should look like a polygon is not equilateral. The conclusion in my conditional statement read the polygon is regular. The inverse statement, the conclusion should look like the polygon is not regular. Same thing as far as hypothesis and conclusion. They're in the same spot. See how it goes red, green? The inverse should look the same, red, green. Okay? Not talking about the red, green show where duct tape fixes everything, but the hypothesis and conclusion. The contrapositive statement should be written the same as the converse, where the conclusion comes first, then we get the hypothesis, but it should be negative. It should be negated. So the converse conclusion reads, if a polygon is regular. In the contrapositive, it should be, if a polygon is not regular. The hypothesis in the converse reads, the polygon is equilateral. In the contrapositive statement, it should be, the polygon is not equilateral. You can see now how the conditional statement and the inverse are written the same, but the inverse is negative. The converse and the contrapositive statements are written the same, but the contrapositive is negative. Hopefully, after this example, you can really understand how to write a conditional statement, which is right here. Let me go through. Hopefully, you can write a conditional statement. You can write a converse. You can write an inverse. And you can write a contrapositive. Now, we learned all that crap, at the beginning of this section, okay, about identifying hypothesis and conclusion. Now, that was very important. Very important. We talked about how to write an if-then statement. Again, very important, because a conditional statement is written as an if-then. And the conditional statement is what we use to write the converse, inverse, and contrapositive. Then we showed you a couple examples of what a converse statement looked like. It was flipped around. Okay? Our example was, instead of talking about parallel lines being congruent, the converse talked about congruent being parallel lines. Then we actually looked at how to write them. Okay? Example 1, we showed you how to write them. Example 2 was all you. Take the statement, if a polygon is equilateral, then the polygon is regular, and be able to write the conditional, the converse, the inverse, and the contrapositive of that statement. And that's really all you're doing tonight for your homework. Let's look at this really quick. When a conditional statement and its converse are both true, you can write them as a biconditional statement. And biconditional, very quickly, bi means two, conditional means there are two conditions. Let's look at this. The definition of perpendicular lines, this is right out of your book on page 81, by the way. The definition of two parallel lines, if two lines intersect and they form a right angle. See how there are two different things there. You can't just have two lines intersecting to be perpendicular, because I can draw two lines that intersect and aren't perpendicular. You can't just have two lines that form a right angle. Okay? But if two lines intersect and form right angles, see how there's one condition, two conditions, biconditional here, then they are perpendicular. It's a conditional statement, but it's got two hypotheses. If they intersect and they form right angles, then they're perpendicular. Hypothesis, hypothesis, conclusion. We would write the biconditional statement like, two lines are perpendicular if and only if they intersect to form right angles. Again, the key to a biconditional statement is the if and only if. Okay? If and only if. We don't deal a whole lot with biconditional statements, so it's okay if you just kind of briefly look at this. You're going to see it a little bit on your homework tonight. But for the most part, it's just dealing with conditional statements. For the most part, conditional statements. Being able to write the converse, the inverse, and the contrapositive statements. And then biconditional is something just extra, okay? If you get it, okay. If not, don't worry about it. There are very few times in this year that we actually see it and that we use it. This is probably the meat, or this is the meat of the section right here, okay? Muy importante. Let's take a look at your homework now.